Now we will perform the nodal analysis when there is dependent source present in the network, and according to the problem we are required to find the power delivered by the 2-volt source. And when you look at the given network, you will find there are 1, 2 and 3 sources present, out of which this source is the independent voltage source providing the 5 volts of voltage, and this source is also the independent source but providing 2 volts of voltage, and this source here is the dependent current source providing 3 times V as the current, and V is the voltage across 2 ohm resistor, and we can say that this dependent source is the voltage controlled current source. And according to the question, we are required to calculate the power delivered by this source, and if we can calculate the current in this branch, then after multiplying the current to 2 volts we will have the power delivered by this particular source. So our main aim is to calculate the current in this branch, and for that we will use nodal analysis. So let's move on to the solution of this problem, and we will use nodal analysis to have the current in this branch. And we know in the step number 1 of nodal analysis we identify the total number of nodes, and in this network we have 1, 2, 3 and 4 nodes present. So number of nodes is equal to 4. Now we will proceed to step number 2, in which we will assign the node voltages and we will choose the reference node. We will take this node, that is the bottom node, as the reference node, and therefore we will ground this node. And now we are left with 3 non-reference nodes, and we are required to assign the voltages to the non-reference nodes, and therefore we will assign V1 voltage to the first non-reference node, V2 voltage to the second non-reference node, and V3 as the voltage to the third non-reference node. So we are done with step number 2. Now we will move on to step number 3, in which we will obtain the nodal equations for all the non-reference nodes. Let's begin with node number 1. So at node 1, this is the current leaving the node in this branch. This is the current leaving the node in this branch, and this is the current leaving the node in this branch. And we know, according to KCL, the sum of these 3 currents will be equal to 0, and this current is equal to V1 minus V3 divided by 1. So we have V1 minus V3 divided by 1 plus this current, and this current is equal to V1 minus V2 divided by 2. V1 minus V2 divided by 2. And to have this current, I will first find out the potential at this point. Let's say potential at this point is equal to V prime. So V prime is the point of high potential, and this is the point of low potential, because here we have connected the ground, therefore here the potential will be 0 volt, and we know high potential minus low potential will be equal to the potential difference or the voltage, that is 5 volts. So V prime minus 0 equal to 5 volts, or we can say that V prime is equal to 5 volts. So here the potential is equal to 5 volts, and therefore this current will be equal to V1 minus 5 divided by 1. So we have V1 minus 5 divided by 1, and the sum will be equal to 0. Now when you simplify this, you will have 5 by 2 V1 minus V2 by 2 minus V3 equal to 5. Let's call this equation number 1. Now we will proceed to node number 2, and at node number 2 we are not required to develop the KCL equation, because here you can see that voltage source is connected between the non-reference node and the reference node. Therefore we can calculate V2 directly. We will begin applying KVL from this point. So we have V2, then moving in this direction we have plus 2 volts, so we will write plus 2. Then we will equate with the potential at this point, that is 0 volt. So from here we are getting V2 equal to minus 2 volts. This is equation number 2. Now we will obtain KCL equation at node number 3. These are the 3 currents leaving the node, and the sum of these 3 currents will be equal to 0. This current we can write as V3 minus V1 divided by 1. V3 minus V1 divided by 1. This current we can write as V3 minus V2 divided by 1. V3 minus V2 divided by 1. This current we can directly write as 3 times V. The reason is very simple. We are having one current source providing 3 times V as the current in this branch. So this current is equal to 3 times V, equal to 0. Now focus on this resistor. Voltage across this resistor is equal to V with this polarity. Now if we apply KVL starting from this point and ending at this point, we will have V1 starting from this point, then we have plus V, then we will equate with V2. So from here we are getting V2 minus V1 equal to V. Therefore we can put V equal to V2 minus V1. So let us modify the equation we are having. We will have V3 minus V1 plus V3 minus V2 plus 3 times V2 minus V1 equal to 0. When you simplify this, you will have minus 2 times V1 plus V2 plus V3 equal to 0. Let us call this equation number 3. We want to calculate the voltage V1 and the voltage V3. We know voltage V2 is equal to minus 2 volts. So we will put value of V2 in equation number 1, and this will give us 5 over 2 V1 minus V3 equal to 4, or we can write 5 times V1 minus 2 times V3 equal to 8. Let's call this equation number 4. Now we will put the value of V2 in equation number 3, and this will give us minus 2 times V1 plus V3 equal to 2. Let's call this equation number 5. Now when you solve equation number 4 and equation number 5, you will get V1 equal to 12 volts and you will get V3 equal to 26 volts. So now we have voltage V1, we have voltage V2, we have voltage V3. Let us now try to find out current in this branch. We know how to calculate the current in any branch following the Ohm's law. In this branch, the current will be equal to the voltage across the branch divided by the resistance offered by the branch. The voltage across this branch will be equal to V2 minus 0. V2 is equal to minus 2. So we can have the voltage across the branch. And now if we can divide the voltage across the branch by the resistance offered by the branch, we will have the current we need. But here we don't know about the resistance offered by the branch. Here we simply have one voltage source, and therefore we don't know about the resistance offered, and hence we will simply use KCL to have the current in this branch. Let's say current in this branch leaving this node is equal to I21. Current in this branch leaving the node is equal to I22. Current in this branch leaving the node is equal to I23. So our aim is to find out current I22, and we know the sum of currents I21, I22 and I23 will be equal to 0. So we have I21 plus I22 plus I23 equal to 0. We want I22. So we will keep I22 on the left hand side, and on the right hand side we have minus bracket I21 plus I23. We can write current I21 equal to V2 minus V1 divided by 2, and we can write current I23 equal to V2 minus V3 divided by 1. So here we will have minus inside the bracket V2 minus V1 divided by 2 plus V2 minus V3 divided by 1. We know V2, we know V1, we know V3. V2 is equal to minus 2, V1 is equal to 12. V2 minus V3 divided by 1 is equal to V2 minus V3. So we have minus 2 minus 26. When you simplify this, you will get current I22 equal to 35 amperes. And our main aim is to calculate the power delivered by this source. So current in this branch is equal to 35 amperes. Therefore power delivered will be equal to 35 amperes multiplied to 2 volts, which is equal to 70 watts. So this is our answer.